Students, in last class, we were discussing about total internal reflection, and coming to this class, we will be studying some applications of total internal reflection. And in the last video, as you know, we have already seen what is TIR and what are the conditions required for TIR to happen, right? But in this video, we will see that how this TIR is applicable in daily life situation. So one such application of TIR today we are going to study. First application is Snell's window. What is Snell's window? For that, let's repeat some concept based on TIR. Let's say there is a pair of media. One is denser media and another one is rarer media. So what will happen that this light ray, when it is incident at some angle I less than IC, what will happen? It will undergo refraction, of course, like that. It will bend away from the normal. But as soon as this I became equal to IC, what will happen? This light ray would be refracted along the boundary of the media. That means angle of refraction was becoming 90 degree, right? Now I will ask you the question that is based on the principle of reversibility. I am giving you a hint that if this light ray is incident along this refracted path, can you tell me where it will be refracted? Yes, of course, along the incident path. If previously it were incident ray and it were the refracted ray, and if the refracted ray were incident ray, yes, refracted ray would have become the this incident ray would have become the refracted ray. Exactly, aren't it? This is the principle of reversibility, if you will remember. So if you got this concept, then you can easily understand the Snell's window. To understand this Snell's window, let's consider a fish that is swimming in a pond, and this fish is actually this fish is at a depth of h meter from the surface of the water, like that. So if you are standing on the surface of the water, yes, you can see this full sky in 180 degree. Human eye can see the things making an angle of 180 degree, right? Let's consider the light rays which are incident from this part of the sky, like that. These light rays are incident like that. So what will happen? This light ray will be refracted, bending away from the normal towards the normal, of course, like that. Similarly, this light ray which is coming from this part of the sky, which is incident from this part of the sky, this point of the sky, it will be again refracted towards the normal and will meet or will reach the fish eye. Similarly, this light ray that will again bend towards the normal and will reach the fish eye, like that. Another light ray which is incident here. That means you can see that angle of incidence for each light ray is gradually increasing. So for this light ray, for this extreme light ray, what is the angle of incidence? Can you tell me? That angle of incidence for this light ray is nothing 90 degree. So it will be again refracted towards the normal, like that. Now can you tell me what is this angle of refraction in this case? In the above case, I already told you in the starting of the class that principle of reversibility. You just keep in mind principle of reversibility and tell me what is this angle. So if I was equal to IC, you already know that angle of refraction was 90 degree. But here I reverse these two angles. That means when I become equal to 90 degree, can you tell me what should be the value of R? That when in that case, the value of R should be equal to IC, aren't it? Of course, that means this value is IC. So however, this light ray which was corresponding to 180 degree angle, okay, that is incident through this path. So can you tell me, can fish eye perceive this bending of light ray? No. Human eye or living beings' eyes can't see, can't observe this refraction. They only observe the result of refraction. So this eye will perceive that this light ray is actually coming from a straight path. That means even if this light ray is corresponding to some what angle? 180 degree angle. Okay. But this light ray will be visible coming from this point of the sky. Similarly, from this side also many light rays will come. Finally, a light ray which was incident at an angle of 90 degree from this sky, right, will be refracted making an angle critical angle, and it will be visible to the human eye or the fish eye that it is coming along the straight path. So that means now you can see, that means this area, this point, this fish eye can't observe. Fish eye is observing only this point. This point will be visible for the fish eye here. Similarly, this extreme point through which we can, that extreme point, the point which we can see from the surface of the water is visible here to the fish eye. That means the fish only can see through this area, right? So if you will see, this area can be visible. So that is a three-dimensional area. So if you will see that this area is nothing but that area is a disk, if you will consider it like that. In three-dimensional means this fish can see only through this area when this fish is at this point. So that means the fish can see through this window, and this window name is nothing but that window is called Snell's window, right? That window is known as Snell's window. Now, what is the criteria, or what is the relation between this height and refractive index of this water? Or what is the radius of this window through which she can see? Let's calculate it. In another diagram, let me draw this another diagram again. Let's say this is the surface of the water, that is fish, and this fish is at a height of, is at a depth of, let me write h meter depth below the surface of the water. Now this fish can see only this point. This fish can only see this point on the sky. Similarly, this side, this fish can see only through this point on the sky. That means the total area this fish can see is nothing but that area. That area this fish can see. Okay, that means the radius through which the fish can see is this radius only. Okay, and that is the depth of the fish. And let's say the refractive index for this water, for the pond's water, let me write the refractive index is mu. Now you can easily see. Now can you tell me that light ray corresponds to the eye equal to 90 degree. So this angle will become IC. Similarly, this side, this angle will also become IC. Right? Now in any of the triangle, you can take any of the triangle. If this angle is IC, let me name these two triangles OAM. Let me write this triangle. If this is IC angle, of course this angle will also be IC. Right? Now, if you will calculate this value is R, this value is H, OA side is H. Can you tell me what is the AM value? Hypotenuse value will be, of course, root over base square plus perpendicular square. That is equal to OM square plus AO square. Right? And you can write it as equal to R square plus H square. Now, why I am evaluating this AM, you will come to know soon. Okay. Now, can you tell me if you will apply sine in this triangle, in triangle AOM, can you tell me what is the value of sine IC? Of course, perpendicular by hypotenuse. Perpendicular you can say is R, and hypotenuse in this triangle is, you can see AM. AM value you have already calculated. R you have already calculated R square plus H square over root. Why I calculated sine IC? Now I will tell you. Because sine IC, we know that sine IC is related directly to the refractive index. Can you tell me how is sine IC related to refractive index? Can you tell me? You already know that 1 by mu equal to sine IC. So you can replace this sine IC by this expression is equals to R by root over R square plus H square. Now, if you want to calculate R, you can square both sides. You will get 1 by mu square is equals to R square divided by R square plus H square. When you will further solve this, you will get R square mu square, right, minus R square equal to H square. That will give you R square equal to H square divided by mu square minus 1. Right? That will correspond to R equal to root over H divided by mu square minus 1. That is the radius of this Snell's window. I hope you got it. Why this fish can't see through this surface? Only she can see through this window. Why she can't see through this window? Can you tell me? What will happen if a light rays incident like that, like through this path? So that means this angle of incidence will of course be greater than critical angle. And if it is greater than critical angle, what will happen? TIR will happen. So if she wants to see, if she wish to see through this surface, through this window, what will happen? These light rays which are going like that will reflect back. That means she will see here what? Whatever the objects are here, she will see the reflection of these objects through this surface. Similarly, this side also, she will see the reflection of the objects which are present here onto this surface.